Okay, let's get started. It's 7 o'clock. Welcome everybody to ASCM APICS Grand Rapids chapter PDM. Tonight's guest is Randall Schaefer. I've known Randall for many years, and I personally consider him the finest consultant in supply chain I've ever come across. And I used to be a former consultant myself, so I have some understanding of that. He's also probably the best educator I've ever come across. I've gone to a number of his seminars. He's taught me a lot, and I owe some of my style and ability to get things done to Randall. So that's kind of my unofficial introduction. Let me read you from Randall's bio, though. Randall Schaefer, CPIM, is an industrial philosopher, writer, and international speaker. He has over 50 years experience in manufacturing. He graduated from Wisconsin State, Stevens Point, and began working and eventually consulted for companies manufacturing household products, agricultural equipment, automotive OEM, and original equipment appliances, lumber assemblies, solar panels, RTA furniture, pharmaceuticals, food products, and industrial machinery. He won the Volkswagen Award for the best presentation by a practitioner at an annual conference of the South African affiliate of APICS. For 20 years, Randall wrote and educated and edited the Lessons Learned feature on the back page of the APICS magazine. So it is a great pleasure to bring forward one of the best consultants I know, and you're going to take home a lot of good stuff tonight. Randall Schaefer.
Thank you, Todd, for that introduction. I will try to live up to the high standard you have set for me. Tonight, I'm going to present a short course in capacity management. This is a reality check for those in operations management. And I will say that the genesis of this presentation was a presentation I did for Professor Stephen Melnick for one of his classes of graduate students in operations management at Michigan State University. I made some changes because that was about people who were going to be in operations management. This is for people who are in operations management. So it's not quite the same presentation, but it's pretty close. If you're going to run a company profitably, the two most important things to manage are inventory accuracy and production capacity. You can talk about lean, you can talk about total quality assurance, all the very important things. But without these two things, it really doesn't matter what you have. Those other things are necessary, but insufficient. These two things are absolutely necessary, and maybe success can come even if you don't have those other things, if you have these things. Now, everybody understands the need for inventory accuracy. Many of us don't have inventory accuracy in our factories. We talk about it. We may even have a blue flag outside saying, hey, we're very organized. We're Q9000 and all that. But when you get down into the factory bowels, the accuracy of the inventory is seldom what it is required to be. I have a whole seminar, an all-day seminar on that subject alone. And I have an all-day subject on capacity alone, but this is going to hit the highlights. So while we understand the need for inventory accuracy, I don't think many people understand capacity management as well as they need to understand it. Now, the textbooks will tell you manufacturing operations manage capacity by maintaining the necessary data, using software to analyze production schedules, and then determine from there the constraints and the excesses, and then finally reacting to capacity constraints and excesses. Now, constraints, of course, means when we don't have enough capacity in the short term, and excess means we got too much. We don't often have to do much with the excesses, but we always should do something with the constraints. Well, that's what the textbooks say. Here's what actually happens in most of our factories. The necessary data is not maintained, and there is no consensus as to output expectations. Because there's no consensus, this results in opinions instead of facts. And when we're suddenly facing a constraint, everybody thinks they know what ought to be done, and we talk about it and talk about it and talk about it until it's too late to do anything. We can't make fast decisions, and inevitably shipments are late. We have turned our indecision and our inaccuracies and put them on our customer in terms of a late shipment. Here's what we need to manage our capacity in any factory. We need data. And then the hard one, we need a consensus on expectations. I'm going to spend a lot of time on that one. We need software, of course. And then, because we will have occasional constraints, we need pre-planned and approved reactions to those constraints. In other words, if we have a constraint on work center XYZ, what are we going to do? And if you say, well, we'll wait till it happens and then we'll see, that's the wrong answer. But that's the answer that most factories work with today. Let's start with data. I think we all understand what a work center file is. They're workstations combined into work centers. If you're going to be lean, then you eliminate a whole lot of workstations and combine them into just a few work centers. That's one of the ways you get lean. I don't think many factories don't get that right. We need accurate routings and time standards. I mean reasonably accurate. That's a little harder because you're not going to get a lot of agreement on the time standards. There's always going to be tough jobs that the supervisor says, I can't make any time this standard. I'm always running a variance. And some engineer will say, well, that's your problem. And it just is left alone rather. That's the wrong thing to do. If you have part numbers, which being while they're manufactured are consistently being in a negative variance as far as the amount of time it takes to make them, then that has to be addressed. You can't just sit there and let the engineers argue with the supervisors. Some manager has got to make a decision and get it right. And by right, I mean closer to what's being experienced. The most difficult one for me to explain to most people is the value of a shop calendar. Every ERP system has a shop calendar, of course, but you really need one for every single work center. So let's say you've got a work center that makes an important subassembly. That work center probably can make many things, but it's geared to make one thing best, or maybe two things best, or maybe one thing of various sizes best. And that needs its own shop calendar because you might want to schedule overtime for that. I also think too few companies have a work center for shipping and for receiving. And that's very important, particularly here in Michigan, where so many of our companies are automotive suppliers. The big assembly automotive plants, they shut down for model year changeover, usually in the fall. And you will get a notice from them saying, as of this date, we will accept no more shipments till after our changeover is complete. So you back off the transit lead time and you say that for shipping, this day and the next day and the next week are not shipping days. But you still have to run your factory. So the receiving days have to show as the shop calendar for receiving shows those as work days. Now, if you go way back in time to the original MRP system, there was only a shop calendar that said this is a work day or this is not a work day. It didn't have weekends. It didn't have anything else. But we're better now. And most of the good systems have shop calendars by work center. And I encourage you to get that right. Now, I've been asked, hey, Randall, how about if the changeover at Ford and the changeover at General Motors do not happen at the same time? But I got to ship to one, but I don't have to ship to the other. Well, you only really need one shipping department physically, but in the computer, you can have the Ford shipping department and the General Motors shipping department, and you can close one down and leave the other one open. The only thing that's required to do that is some very simple programming. So when an order comes in, it identifies itself as going out eventually of one of those two shipping departments. Shop calendars can be complicated, but if you understand how they work, you can really use them to fine-tune your operation and eliminate a lot of confusion. The next one is a production plan. Whether you manufacture to order or you manufacture to stock, you're going to manufacture to some kind of production plan. You may replenish based on a min-max system of inventory in finished goods. You may launch orders the day you get an order, if you're making to order. A lot of ways to do it, but everybody has a production plan, and the production plan has to be entered into your ERP system or your old MRP system. And you have to follow that. One of the things that you're going to get in a production plan when it runs through the computer is it's going to back off lead times. Lead times are kind of like your time standards. They have to be pretty close, but you can live with minimal variations. What you can't live with and should not live with is when some part number being manufactured consistently runs over standard. And you can see the part numbers because all these computer systems, they will give you part number by part number variances. And variances are seldom caused by having spent more money than you're used to for the raw material. It's almost always that it took too many hours or minutes to make what you made. And those things should be looked at. And if a part number pops up once every couple of months, I don't care. But if it pops up consistently, like 2 out of 3 times when you make this part, it runs a variance, some manager ought to investigate that. It seldom happens. If anything happens at all, you'll get a fairly weak manager saying something like, hey, Joe, you're running a variance every time you run that part number. Now get it under control. Well, I'll guarantee you, Joe did not want to be scolded by his boss. If it was possible for him to get that under control, he would have done it. Obviously, old Joe needs help. So give him some help. Don't just tolerate it and expect that the other guy is going to fix it because it needs fixing. That seldom happens. You got to manage those lead times, and you got to make them as close to accurate as you can by attacking those constant and repeated variances. Well, that's just data, and that's one of the easy ones. Here's the hard one. A consensus of expectations. What this means is I believe everyone with the authority to say no to overtime or any other response to a constraint must agree to some standards. Now, who can say no to overtime? Well, if you're in a union environment, the employees maybe can say no. Probably not the first line supervisor, but his boss, a lead person, a general foreman, a plant superintendent, a plant manager, maybe a director of operations. There's probably a whole long list of people who have the authority to say no. And the farther up that chain you go, the less likely it is that you're going to get a yes. You'll probably get a no. because the further up the chain you go, they understand money more than they understand taking care of the customer. And if you don't maintain your output expectations, you will eventually disappoint your customer and ship late. So I'm saying that everybody in your chain of command who has the authority to say no has got to come together and agree on what constitutes a yes and what is okay to be no. And that means for every work center, how many hours must be worked each shift? That's a measure of utilization. For each work center, how close must the output be to the time standards? That's a measure of efficiency. Utilization times efficiency equals effectiveness. So you have to have an agreement on effectiveness expectations. And that's simple. It's the standard hours of output that can be reasonably expected per shift for each work center. And the most important thing is once you have that agreement, you can't mess around with it. You have to react to a failure to achieve these expectations. You can't stand around and think about it and talk about it and smoke a peace pipe over it because it's going to be too late and you're going to end up shipping late. And there's a timing standard to this reaction. For instance, a small output shortfall for a few shifts may not require any reaction. You only missed it by a little bit. But a big shortfall for a few shifts always does require a reaction. And managers who are resentful of the capacity agreement, they will try to delay the reaction. So a separate agreement is needed for the timing. And let me give you an example of the ones that I would set up when I was consulting. A 10% shortfall for one shift requires a reaction, or a 5% shortfall for two shifts in a row requires a reaction. It's easy to see how to do this. It's hard to get people to agree in advance. Somebody will say, well, we'll see how it goes at the time. No, that's a wimpy manager. You don't see how it goes at the time. If you're missing your due dates, you're missing your output, you react. You don't talk about it, you react. Now you got to keep it reasonable. If you go nuts over this, it'll just kill the agreement. But most people won't go nuts over it. Most people will go nuts trying to prevent it. Yeah, I agreed to it when we set it up, but now, I don't know. We worked a lot of overtime. And my favorite, I actually had a boss once that looked at me and said, if we work the overtime you're suggesting, what will we be able to ship by the end of the month that we otherwise would not be able to ship? And I just looked at him and said, it really doesn't matter. Because somewhere down the road, we're going to be late with the customer. And that's never a good thing. Work the overtime. Do the other things if overtime isn't enough. You have to do something. You can't sit and talk about it when the time comes. The third thing we need is software. The software will take the data to analyze the production schedule. And it'll tell you in advance what the variances are between the output required and the expected output for each work center. It'll tell you where you're going to have a shortfall. It won't tell you what you have to do about it, but you must do something about it. You never let the computer make hard decisions anyway. Those are for human beings. So it won't tell you how to react, but it will tell you that you must react. And the way you react is not after it all hits the fan. You have to pre-plan the approved reactions. There are many work centers that will never be overloaded, and your veteran employees know exactly which ones those are. And they also know which ones are likely to be overloaded, and they also know which part numbers go through that work center that cause the biggest problem. So you address that work center's constraint or anticipated constraint by focusing on the part numbers that go through that work center. Now, the most common reaction when you have a constraint is to schedule overtime for the duration of the constraint. Now, overtime may be voluntary in union environments, but usually that's not the problem. The problem usually is the company will schedule overtime without first determining the duration of the constraint. Now, this is just silly. This is like saying, well, we'll work 2 hours overtime each night for a while. For how long? For a while, until we get caught up. How long will that be? If you can't answer those questions, then you haven't done the homework. By the time they realize the backlog is growing instead of shrinking, it may be too late to prevent late shipments. My stern recommendation is never schedule overtime without knowing the duration. Don't schedule the overtime unless you know. I'm going to work the 2 hours overtime on Tuesday through a week from Thursday. And then we won't need the overtime anymore. And if I don't quite get all the output I need, I'll work Friday and Saturday too. That's the kind of durations we're talking about. Know in advance how long the overtime is required. However, sometimes overtime is not enough. Sometimes you're going to have to offload to another machine or subcontract to an outside supplier, in which case you select the part numbers that require lots of hours on the constrained work centers. Now, when you're determining whether offloading or subcontracting is a better solution, you have to pick the part numbers that are easiest to offload or subcontract. Now, I know in the case of subcontracting, you've all maybe experienced this. You had to subcontract and there's 14 different part numbers that will go through a specific work center. And the supervisor wants to offload to somebody who's never made them before, all the dogs and cats that he can't make efficiently himself because the dies aren't quite right. They take too much messing around with the part, too many operations. He wants to keep the good and easy stuff and offload the difficult stuff. Well, of course, if you're the subcontractor, you need the easy stuff because you have a chance of getting that done right without scrapping the raw material and holding down the lead time. And once you know what these offsetting dollars are for offloading to another machine that's less efficient or subcontracting to another supplier at another cost, you'll know which one to do. And then test the solution to assure quality standards can be maintained. So if you got machine center XYZ, and you know that occasionally that becomes constrained, and the two part numbers that give you the most problem there are part number A and part number B, then have the subcontractor make a run of part number A and part number B and run them through all your quality tests and get them certified as capable of doing those. Don't wait till it hits the fan on work center XYZ and then say, maybe Joe down the road can make these for us. That's way too late, and there's no assurance you're going to get back a quality product. If you just, and once you prove that old Joe down the road can do the job and they has met the quality standards, then issue a purchase order in advance, agreeing in advance to the cost and the lead time. Because once the constraint is visible, you want to react immediately. You want to react, well, I don't know how far out you're going to run your ERP run, but usually you can see things a week or two in advance coming at you. And by that time, you can have the raw material down to old Joe and back. But only if you got purchase orders issued in advance, quality standards understood in advance, and prices agreed to in advance. And I want you to do all of this today on all the machines that are subject to occasional bottlenecks. Don't start after the constraint, after the bottleneck is upon you. That is the wrong time to react. Always react before it hits the fan. Now, there's some problems, of course, with offloading and subcontracting. There may be a longer lead time for the guy down the road. And if there's a longer lead time and you have to supply the raw material, you may have to do the initial operations earlier. And even if you just give them the raw material to work with, but the raw material may not be available earlier if he's got a longer lead time than you. And that unfortunately means you may have to stock some raw material in anticipation of having to outsource it. But a small increase in inventory is a very small price to pay for reducing the chances of late shipments to your customer. Nobody ever went out of business by having a little too much inventory. Even if it wasn't the lowest possible number that the accountants love, that doesn't matter. The only thing that matters is you don't miss shipments to your customers. You do go out of business for that, not for having a little excess inventory in anticipation. Without the consensus agreements, you're going to get hostile opposition to this. Accounting is going to say, I don't need any of that raw material. That doesn't mean anything. That what you're worried about may never happen. Yep, it may never happen. But we're doing this because it has a history of that work center of happening. The prevailing attitude in most of our factories, I'm afraid, is operations managers at all levels have never worked with an effective capacity management system. Their concept of capacity management is to scramble with overtime after the bottleneck hits the fan. And if the shipment goes out before the customer cancels the order, they believe they've reacted well. They've succeeded. They're going out and have a beer later and buy a beer for everybody who helped get the thing done. Anything more complex than that is viewed as pie in the sky theory for professors and operations management students. But it isn't, because any employee who volunteers to update the data, keep it accurate, that employee can be the company's savior. And if the data can be kept accurate, you actually have a chance of gaining consensus on the output expectations. But where your inventory is not accurate, your lead times aren't accurate, your bills of materials are probably right, but your time standards aren't accurate, well, no wonder people then argue, because they can. But if everything is kept accurate, you might actually be able to manage capacity. The big companies do it very well. And this will set your company, and you will be the hero of your company. It'll set you apart. Now, I have way too often run into a particular silly attitude. And that attitude, I'm going to paraphrase it, is we don't need to manage capacity because our factory embraces lean principles. Ooh, good. Well, those people have fallen into the constraints trap, and I urge you, don't join them there. Let me define the constraints trap. Management will always prefer a lean effort, hoping to avoid buying additional equipment. And you know how the lean efforts work. It works fine. It incrementally improves the efficiency. You get more pieces per hour out than you could before. And maybe 2 weeks later, you get even a little more out because you're still getting leaner and still doing better and learning more. And you can therefore avoid buying additional equipment. And management focuses on managing this constraint day to day and diverts attention from determining the size and the duration of the constraint. Just because you're doing lean and gaining some output with it doesn't mean that's enough. It may not be enough. And by the time we realize that managing the constraint is not enough, it's going to be too late. You're going to make some late shipments. The main lesson of the constraints trap is lean does not add capacity. Lean improves work center efficiency and utilization to increase output and reduce cost for selected products. And that is purely wonderful, but oftentimes not enough. Here's what lean can do for you. You take 100% effectiveness, subtract from it whatever your historical effectiveness is for any work center, and that equals the maximum additional output lean can provide. Now, most people will say, we're never going to achieve 100% effectiveness because stuff happens. I saw it on a bumper sticker once. So even if we were at 100% effectiveness, sometimes that's not enough. And so lean isn't going to get you there. You got to know that in advance. Always take advantage of all the lean things you can, but recognize sometimes that will not be enough. Now, I managed to pull this off at one factory, actually 2 factories, one when I was working at, one when I was a consultant. It's a great strategy, but only for some people. If you have a factory where similar products are produced on an assembly line, my experience is with refrigerators, assure that each feeder area, subassembly, fabrication, paint, all work centers that feed the assembly line, assure that they can outproduce the assembly line. So if you don't overschedule the assembly line, you can't possibly overschedule any work center in the entire factory. That's possible some places. Most places it probably isn't, but you might be able to do it on a couple of product lines, but maybe not everything. I want to emphasize there is no substitute for capacity management, whether you manufacture to order or you manufacture to stock. Whether the factory is a traditional environment or a lean environment, you must always assure that you can produce the production schedule. Managing capacity, in addition to managing inventory, is the only way you can do that. I want to thank you for your kind attention. I will now open up the program to questions. Who would like to throw something at me? Well, Todd, apparently we're done. I guess I was so definitive that nobody has any questions about anything. I guess that's, I hope, or maybe I put them all to sleep. It's all yours, Todd. Thank you.